Awesome. Howdy, y'all. My name is Lydia Salsbury. I am a master's student at The Ohio State University, and I am looking at grazing management practices on productivity and carbon footprint of grass-fed beef for the state of Ohio. So in this project, I'm exploring the grass-fed beef production scenario in Ohio, all the way from our grass to our package. And that means I'm going all the way from the farm, doing soil and forage testing, to processing facilities and evaluating carcasses. So I'm comparing different management strategies in terms of their environmental impacts as well as that business perspective. And I'm going to be developing on-farm carbon footprints once all of this data has been really analyzed. And the inference is that as more strategies that are being deemed improved by this project, which I will go over, the product quality and yield will increase, while the impacts on the environment that are considered negative will decrease. So one really important aspect of this project is that it is a systems project. That means it's a holistic approach incorporating multiple disciplines to analyze agroecosystems as one unit rather than looking at one portion of it. It's looking at interactions and allows for more trade-offs to be identified, making it more applicable to a real-world scenario. So one way to really look at this is in traditional, more reductionist studies, you would look at the cow and the meat, or you would look at the forage and the meat, or just two aspects together so that you could get rid of some noise. Whereas in systems thinking, you're looking at it all together. You're looking for interactions, you're seeing how the cow is impacting your meat from your soil, and then your forage impacting your cow. You're looking at all of those. So then I did say, here are my management strategies that I was looking at for this project. We looked at whether you were rotational grazing and how, what your grazing targets were, what your forage diversity looked like, your weed control strategies, how you supplemented, how long your season was for grazing, how you managed for bare soil, pasture rest, grazing residual, overseeding, production, and then unique practices. I'm going to take a quick moment on that because it seems like a weird thing to have in my management strategies. But as I was visiting different farms and getting the opportunity to see how producers were managing, some farms had very unique things, such as in this image, you can see that barn. It's called a hay shed, and it was a unique approach to overwintering to create a manure stockpile and prevent negatively impacting those pastures or having a sacrificial pasture. So for this project, we didn't apply any treatments, we were observing. So it's extension based and it's a quasi-experiment because we didn't specifically assign our treatments, but our farms volunteered. Because we didn't assign or control, we created a scoring system to allow for a quantifiable comparison between farms. Each farm had very different management, which allowed for a good representation of different strategies. The baseline score for an average farm would have been 0. There was a potential to go into negatives, but all of the farms were performing well, and they were all above that 0 threshold. So then let's talk a little more on this scoring. For this project, the scoring was productivity-based, not ecological. It had a point scale attached to each strategy, which I'll show you later. And so the points for each strategy were then added to create a farm score. Some of these strategies did have to be evaluated by field, and the fields were averaged to give 1 point value for that category for a farm. It took some fine-tuning. There were gaps at the beginning, but it actively evolved and developed as we scored farms and visited farms. And so the final scoring was as accurate as we could make it for this project. So to really walk through this, I have a scoring example. So here is the field that we'll be looking at. This is how this field scored, or this farm scored. It had a long-term rotational. Long-term for this project was considered more than 3 years. Grazing targets, they were using quality and height. They don't fertilize according to a soil test. They were just applying manure. Hay supplementation, it was a single source hay. They had 10 months or longer on their grazing season annually. They had unique practices. They were resting an ample amount of time for their pastures. Forage residual was between 40 and 50%, so that was about average. Their overseeding frequency was, they didn't really overseed because they used those tillers and just plants going to seed head. And then for farm production scenario, they were a stalker operation. So one of our individual field scoring things was our forage diversity. So here I have images of that same field, but more zoomed in, where you can see they had white clover, bluegrass, knobble, fescue. Johnson grass is here because this farmer considered this to be a positive species and did indeed plant it. Red clover and Indian grass. So for those field-specific scores, we have our forage diversity, which, as you can see, that field was very diverse. Undesirable species, which is your weeds and things you don't want there, and then bare soil, which thankfully most people don't have a whole lot of. So what did we measure in this project? We were measuring everything from soil, aggregate stability, bulk density, total carbon and nitrogen, organic matter, forage, quality and yield. Gases, we looked at enteric methane in vitro and soil emissions. For product, we looked at quality and yield. And then for our carbon footprint, we're creating a farm gate footprint for each farm. Some preliminary results. First, I want to do a callback to Dr. Chris. Drought was a big deal this year. And while we may not have seen everything we expected, there was a lot to be learned about management resilience that we may have otherwise missed. These lines reference the annual average rainfall for Ohio in these months. And these bars are what these farms actually experienced. So as you can see, some farms were more and less impacted by this drought, but everyone did have below average rainfall for at least 2 of those months. So for soil collection, we did bulk soil samples and undeformed cores. As you can see, we would collect them with probes and slide hammers, and we did have a drill, thankfully, to get to our 2-foot depth. So some of the preliminary results I'd like to look at is aggregate stability was fairly level across because most of these farms did have the same inherent soil conditions. Farm 4, which I believe is purple, had the only different soil being non-glacial, but they were all alphazols and it was pretty stable, so not very much significant difference. We also haven't seen much in terms of a significant difference for your carbon to nitrogen ratio, which is important because the higher the number, the more brown material if you're into composting, and the more green material or nitrogen, so lower the value, the better things will generally grow in it. So for forage, we used nears to get a quality, and we did forage yield by collecting squares, the 1x1 squares, and drying and weighing. Here you can see images of things being run. So this is where we saw a ton of seasonal differences. So I have spring, summer, and fall respectively. One thing that's a little bit surprising was that fall was so much higher than even spring. But as you can see, there is a trend up. The line denotes quality, the quality threshold though, and all of the farms performed admirably across, even though we had that rough summer. So that is something that I think everyone can be happy to see. And then relative forage quality, we also have this threshold for quality. And once again, we are remaining above it with that seasonal difference. So then we have gases. Enteric methane in vitro was what we did to get a methane estimate from these farms so we could compare how much methane they were relatively putting out. So this was performed by taking ground forages from each of the fields. I collected rumen fluid from donor cows, the same donor cows across the project, had buffering material, put them in a shaking incubator for 24 hours, and then collected headspace gas pressure and headspace gas to run on GC. And then we have our product measuring. For product, I went to every processing event for these farms. These are example ribeyes from each farm. Above, we have our farm scores and our farm numbers, and below we have the carcass weight for this animal in particular, and the grade that this specific animal received. All of these are A maturity, so none of these are older cows. I did not include culls here. but the quality and yield were evaluated to give an idea of what these management scenarios are producing, because at the end of the day, I can tell you that it's great for the environment, but if it's not going to produce a good quality product, why would you do it? So we have seen that some of our higher scores are matching up with our higher grading, but I'm looking forward to having more time to evaluate these connections. So then our plan for carbon footprint is to do a farm gate footprint, utilizing all of these values in the carbon stock information. And preliminary conclusion is that our goal of finding the connection between improved management, improved product, improved forage, and improved soil health is coming up. And so hopefully we continue to corroborate this. But with that, I will thank y'all and open for any questions you have for me. Oh. Yes, sir. So I used USDA ribeye dot grids, USDA standards for grading, and I had Dr. Elida Garcia with me, the state meat extension specialist, so that all of these, she is a grader, she can do that. So she has checked every result and made sure that they are all consistent and accurate results.
So my question was, is the standard system for grading, is that applicable to grass-finished beef, or should we be using another system? And did you evaluate palatability of the beef?
So to answer your question there, yes, the standard USDA criteria is effective for this, I would say. They are still beef carcasses, and they are still going to have similar eating quality in the sense of more marbling is going to give you more flavor. And a lot of studies have shown that like the fat health benefits are different, but that doesn't change the basic physical marbling scores and yield grading. So yeah, I would say that the USDA standards are applicable to grass-fed systems. In terms of eating quality, we have not done consumer panels on this. We are estimating eating quality based on grades. But in the future, if this project gets continued, which hopefully it does, we can add some more tenderness testing. We can do some consumer panels potentially and really look into differences on that end further. Yes, sir? So for genetics, we normalized these farms. We only picked farms that had Angus breeds. So we didn't want to have any like Hereford versus Angus marbling differences. So all of these animals were Angus-based breeds in this project. Okay. So I'm going to hop back there just because I think it'll be easier to have it up. So for, let's say, the big score sheet, we based this off of some ecological scoring models, but the way we kind of did this is we looked at different papers that were doing grazing management and saw what strategies were generally considered improved. So in our CS fact sheets, things along those lines, to see what they were saying are improved. And then while we were in the farm, when I said that we did a lot of fine tuning, we would see in farms that maybe we could have our bare soil have a tighter threshold than what, say, in our CS would have. Like, we can say 5% instead of 10%. And so that's where some of that fine tuning came in. But for the most part, we did base this off of what industry and what fact sheets and extension had been saying, and just fine tuned it for what we were seeing. Yes, sir? So we did do soil aggregate stability, but we did not have the opportunity to do water infiltration due to time constraints. If there were future, if there are future moves in this project, that could be a really interesting thing to add. Anyone else? Awesome. If anyone has any other questions or wants to talk to me, feel free later. I will be here all day. Thank y'all.